Okay, so let's talk about 8.5, which is trig ratios of any angle. So what's going to happen is we're going to combine two concepts. So we have found the trig ratios that were, since they were all positive, they were basically in quadrant 1, even though we didn't locate them that way or even describe them that way, okay? So we're combining the trig ratios with, what if we put them on the xy axis for all four quadrants? So what that means is now, since we're moving it all around the xy axis, if we go to the left, we might have a negative value. If we go down, we might have a negative value. And so some of our answers will be positive, some will be negative, and you need to understand the difference of when, all right? So let's go ahead and just talk about some of the concepts. So as a review, this is quadrant 1, quadrant 2, 3, and 4. Okay, now all of these are going to be with right triangles, and so we have to have a uniform way to draw the triangle in each quadrant so that all of us have the same exact triangle drawn, and we would label the sides the same way, the angles the same way, positives and negatives, okay? And so that's super important. So there's two rules. So number one is the triangle is always going to be straight down to the x-axis. So number one is to x-axis, okay? And number two, this one's probably more important, the angle is always by the origin, okay? So let's go ahead and go through what that looks like in each quadrant. So if we are told, like that says quadrant 2, you'll always be told which quadrant it's in, you won't be guessing. If we're in the first quadrant, you're going to draw a dot, and you don't want to make it too close to the corner because you want enough room to draw a triangle so you can label it, okay? So I just make it far out. You're going to go straight down to the x-axis. That's what I mean. And since we go straight down, that makes the right angle. And then you're always going to take that dot and draw it to the corner. And so we have a right triangle. You're never going to go to the y-axis, and theta is always going to be the angle that's by the origin because you have two angles, and so you need to know which one we're referring to. This is always. Let's do quadrant 2. So in quadrant 2, same thing, draw a little dot far away. We're going to go straight down, which makes the right angle, and you're always going to go to the origin, so theta is right there. Okay, so notice if we're in quadrant 2 and this side is on the x-axis, those numbers are negative, okay? All right, let's do the third quadrant. So in the third quadrant, draw a dot. We're going to go straight down and to the origin, so theta is right there, okay? And so you're only going to have one of these triangles at a time, but if you don't know where the angle is, and if you draw your triangle to the y-axis, our values will be different, okay? And so our last one, fourth quadrant, we're going to go straight down and to the origin, and so theta is right here, okay? And so like I said, if we're up above, it's positive. If we're to the left, negative, things like that. As a review, these are still the same 3 trig ratios with the same words, okay? So let's try one, okay, before I do the steps. The first thing that I would do is draw an axis. I'm a visual learner though, so to do this all in my head, that's just actually impossible for me, just so you know. There's too much to keep track of. So definitely when you're doing your student practice, you'll want scratch paper, and if you're on the quiz, insert pictures of your work if you're not like doing it on the screen or anything, okay? So first thing I do is I figure out where are we? So we're in quadrant 2, so I'm going to go 1, 2, and I draw a triangle. Like I said, I'm a visual learner, so pictures usually help me. And then label your angle in the corner. Okay, it has to be there. Your triangle has to look like this. It's really easy to be confused. This is not an easy section, so I will warn you, if you have not done the other sections in Unit 8, you definitely need to go back and do those first before you attempt this section. This combines so many ideas that it is actually pretty difficult if you're not building on the other skills. All right, so what we know is sine, which sine is opposite over hypotenuse. So remember, hypotenuse is across from the right angle, so I'm going to label this as 5. Now, there is a rule. The hypotenuse is always positive. Because it's a diagonal, it gets a little tricky, but mathematically, there's a reason why it is positive. So hypotenuse is always positive. Now, the side opposite is 3, so it's opposite the angle, so I go across and I label that as 3. And notice we went up, so that should be a positive, and it is. All right, so that's important, just to double check. What we want is cosine. So cosine is adjacent over hypotenuse. And we already know our hypotenuse is 5, so that will not change. We need to find the side that's adjacent, okay? Well, in order to do that, we need the Pythagorean Theorem because it's a right triangle. So my two legs, I've got a squared plus b squared equals my hypotenuse. So 9 plus b squared equals 25. Subtract 9. We get b squared equals 16. And to solve, remember when you take a square root, because that's the opposite of squared, we actually get plus and minus. And you want to break down 16, which is 4 times 4, into doubles. So the square root of 16 is positive 4 or negative 4. So depending on where our triangle is, we'll decide which one that we want. So I know it's 4, and I need to look. So if this is my origin, and we went to the left, I know this would be a negative 4 to show direction. And that means adjacent is negative 4. So my answer is negative 4/5. Now, you can write it as negative 4 over 5. You can also write it as a negative in front. And you technically can put the negative in the denominator, even though it's really not there. In order for it to be negative, you just have a negative sign anywhere, okay? So just to review, that we're not assigning it. It's just denoting that the whole value is negative somewhere. Okay? All right, so for those students who like some steps, I wrote 5 of them out. Okay? If you don't like steps and you can just remember the process, then great. But first you're going to find the quadrant. You're going to sketch your triangle. Make sure you do it correctly. Label what you know. Find the missing side with the Pythagorean Theorem. And then set up the requested trig ratio. All right. Now, notice these are good if you like to double check if your answer is going to be positive or negative, because that's what you're going to miss like 1/4 of a point for. So notice here, if we were in quadrant 2 and I wanted cosine, here's quadrant 2 and cosine, it said cosine should be negative. And our answer was. So what would happen is if I forgot my 4 here and then I double checked with this little note, I would say, ooh, just slap a negative on. Okay? Or vice versa. If you made it negative and it was supposed to be positive, just take it off as long as you felt confident in all the other math. Same thing for tangent. These are all the values, positives or negatives. Okay. So remember, you can use notes on your quiz. So if you like this to help double check you, I would definitely write it down and use it. All right, let's try these problems. So on example 1, we've got quadrant 3. So I'm going to go 1, 2, and here's 3. Okay. My angle is always by the origin. Here's my right. And so I'm going to label what we know. If this is cosine, cosine is adjacent over hypotenuse. Now, we always, when we write it in the directions, we put the negative in front, so you don't know if it's going to be on the 12 or the 13. And it really just depends on the problem and where you are. But we know that our hypotenuse is always positive. And so that means that that 12 is negative. So the side adjacent of the angle should be negative 12. And look, we went to the left, so it should have been negative 12. Okay, so they should make sense together. If something doesn't make sense to you, then something else is missing, because there are some other options sometimes. All right, for tangent, tangent is opposite over adjacent, and we know adjacent is negative 12. Okay, so I'm just going to go ahead and include that. So I need to find my opposite side. We got Pythagorean theorem. So a squared plus, make sure you use a parenthesis around the negative because it does matter, and then 13 squared. So we get 144. Like I said, you can pause this if you want to try these problems and then hit play to like help catch your error or see if you are correct. You don't have to just watch me do them if you don't want. Okay, maybe watch the first one and do it on the second example. That's really your choice. So we're going to subtract. I got 25. To take the opposite of a squared, we take the square root. A equals, it's always plus and minus when you take a square root. And 25 breaks down into 5 times 5. There's a double. There's nothing left for a single. So you will be breaking down roots. So now I know it's either going to be positive 5 or negative 5, and we have to look at the picture. So if this is the x-axis and I go down for this side, that means it should be negative 5. Okay, so I get negative 5 for my opposite side. Now, I don't want to leave my answer as negative 5 divided by negative 12. We still do simplify because it is a ratio. We don't write these as decimals though. So 2 negatives make a positive, so I just get 5 over 12. Okay. There are a lot of skills being combined on this one problem. This gives you a little taste kind of the complexity of Sec 3, just so you know. All right, let's try example 2. So on example 2, I always draw my axis. We're in quadrant 4. So 1, 2, 3, 4. I'm going to go straight down to the origin and I draw my angle. Notice I do that before I even worry about any of the values. Tangent is opposite over adjacent. One of these is negative and we're not sure which one yet, so let's use our picture. So I'm going to go to my angle and the opposite side is root 7, the adjacent side is 2. So which one needs to be negative if we use directions? So I go to the right, yep, that's positive, and I go down. This one should be negative. Okay, see how it kind of matches? So I'll go ahead and just circle so I know those are together. So sine is opposite over hypotenuse. So the opposite side we already know is negative root 7. So Pythagorean theorem. We get a squared plus negative root 7 squared equals our hypotenuse squared. This is a tricky one. Well, 2 squared is 4. A negative squared is positive. Root 7 squared, remember those cancel, so I just get 7. And remember, it should be plus. Well, I get to add these together. And so I take the square root, so C equals plus or minus root 11. It depends. We want the hypotenuse, so we know it's going to be the positive root. All right, now this is where you have some options. You have to really be flexible. And this is what I mean. If this is not multiple choice, I will take this answer. So negative root 7 over root 11, which can also be written as negative and one big root. Okay, these are both fine for me. In Sec 1 and Sec 2, we do tell students to rationalize their answers, but when you get to calculus, you actually stop rationalizing. So I do want to introduce that idea to you. Now, let's say it was multiple choice. That could be one of the answers. Let's say it's not though, and they did rationalize. So let's review rationalizing from semester 1. So I've got negative root 7 over root 11. Rationalize means to multiply by the root that's in the denominator on both, okay? And so we multiply the insides on top. I get negative, and then 7 times 11 is 77. Neither one of those broke down to simplify. Root 11 times root 11 is 11. So this is a great answer as well, and it's rationalized. So if it's not multiple choice, I'll take any one of these 3. I don't think one's better than the other, just so you know, mathematically. They really aren't. I will not take decimals, though. If it's multiple choice, you have to be flexible enough to know how to get whatever answer that they're looking for. Okay? All right. Let's go to our last example. So we're going to make a triangle, quadrant 2. So 1, 2. Sine is opposite and hypotenuse. So opposite, I get root 13. The hypotenuse is 2. Actually, we can't do that, so hold on. Let's make this, I'll change it to, I don't want to, let's do 12. Okay. Don't worry, I'll change it on your worksheet so you won't even know. Okay, so I want tangent, which is opposite over adjacent. So we know opposite is root 13. Okay. So we need to find adjacent. We get our two legs are root 13 squared plus we don't know the other one, and our hypotenuse is 12 squared. Well, root 13 squared is 13. You can use a calculator to do that. 12 squared is 144. So if I subtract 13, I get 1, 3, 1 equals b squared. And then we'll take the square root. So b equals plus or minus. Well, root 131 is kind of an odd number, but it's not even. I tried 3, 4, 6, 8. No even numbers will divide if 2 doesn't. 5 doesn't work, 7. So typically if you try the numbers 1 through 10 and it doesn't work, then it probably doesn't break down. There are exceptions, but so we're going to leave this. And so we need to figure out if it's positive or negative. So since we went to the left, we're going to look at the negative. Okay. So we get negative 131. So I will take, let's go ahead and write a little divider. We get a negative in front, and then root 13 over root 131. I'm okay with that answer. They'll also write it as one fraction, or let's say they rationalized it. So let's go ahead and rationalize. I've got root 13, root 131, 131. Now, 13 and 131, those are both prime, so I can't break them down, so I'm just going to have to multiply them back together, and it is going to be really big. I got 1703, so negative root 1703 all over 131. Or, let's say, negative root 1703 over 131. I literally am fine with either answer. As long as it's negative and I see it's rationalized or not, that doesn't bother me at all. I think there's enough other skills here that are testing the knowledge that's important. So go ahead and give those problems a try and see how you do.